Today we begin the process of looking at the full year of an introductory chemistry course. Now, as we begin this, the first sentence you always hear is the definition of chemistry, and it has to do with this notion of exploring matter, trying to figure out what matter is. There are a variety of different ways to go about doing this. One of them is the sort of phenomenological approach where you go out and you walk around and you see things and you try to explain them. Some people went out and saw things and tried to explain them by categorizing them. They would be able to find, for example, a collection of different kinds of inert gases that didn't react. They would find some metals that tended to explode when they put them in water. And they ended up doing things like building the periodic table because of this, all without having any idea about the fundamental nature of the matter that they were exploring. Other people would go out and they'd start doing different kinds of quantitative measurements on the matter they saw. They would do chemical reactions and develop this notion of stoichiometry. They would go out and make measurements on gases because those were easy to contain and experiment with and come up with a quantitative model for the gases. That's why you see sometimes as you begin reading different textbooks that there'll be different strategies for how you approach exploring chemistry. From the perspective of looking at stoichiometry, from the perspective of describing matter, from the perspective of looking at gases, liquids, and solids. This particular approach is different from that. It's an approach that's built on this notion that before you can start explaining everything, you need to know the essence of what it is. This is this idea of an atoms-up approach to explaining chemistry. So in the very first chapter, we delve right in and take a look at what the fundamental particles are that are responsible for the chemistry we're going to watch. Now, an appreciation of what those fundamental particles are has a lot of philosophical implications going way back many centuries as people thought deeply about what was going on, and some people guessed better than others as to the actual nature of matter. However, the experiments that occurred that allowed people to start seeing what the fundamental particles were actually took place about 100 years ago, a little more than 100 years ago. And that's where a lot of very famous experiments came from, and I'm not going to spend much time talking about them, other than to remind you that these are things that you learned about in high school. This is a cartoon of the Milliken oil drop experiment, where they first started understanding the mass and charge of an electron as a fundamental particle. There was the famous Rutherford experiment that took place in the early 20th century, in which there was a firing of alpha particles at different kinds of foils. And it was from that that they came to appreciate that this negative charge of electrons was passing by a very densely packed, positively charged nuclear core. So as we begin the presentation today, what we appreciate is that there is, in fact, this model of the atom, and that this model of the atom involves the notion that, in fact, there are protons and neutrons that sit inside a nucleus and that they have a positive charge, and that, in fact, most of the volume in the atom is taken up by a collection of electrons that seem to be in this kind of sea or soup that floats around that positive center. The reason that we're so interested in understanding these fundamental particles and their behavior is because it is out of knowing about them that we can start to make decisions about how chemical compounds form, the bonding that takes place to make chemical structures. And then from there, to be able to go on and start talking about the chemical reactions that take place.